Okay, can you describe what's on the screen real quick? We are developing this web application at the moment, but we need the summary of what's currently going on, and then we go over how to improve it as well.
Okay, the screen displays an interactive simulation titled Penis Function. It uses abstract shapes to represent different parts and processes like arousal, ejaculation, and urination. The buttons at the bottom allow you to control the simulation, triggering different functions and resetting the demo, with options for sound and other settings.
Okay, and how realistic this simulation is and how scientifically accurate it is?
Well, based on the visual style and the simple buttons, it seems to be an abstract simulation, focusing on demonstrating the basic functions rather than being anatomically realistic or scientifically detailed. It's more for conceptual understanding.
Again, how would you go about improving it?
To improve the simulation, you could consider adding more detailed anatomical representations, incorporating labels or nations for the different parts and functions, and potentially increasing the complexity or interactivity to provide a more comprehensive understanding. Making it visually more informative could greatly enhance the user experience.
Okay, can you elaborate on that? We would like to actually send a standalone brief for a developer, for an experienced developer.
To improve the simulation, you could focus on several areas. First, enhancing the visuals to be more realistic and anatomically accurate would make it more informative. Second, integrating labels, tooltips, and clear explanations for each component and process would greatly enhance the educational value. Third, improving the interactivity, perhaps allowing users to manipulate different parts or explore various scenarios, would make the experience more engaging. Finally, ensuring a user-friendly interface with clear controls and smooth functionality is crucial for a positive user experience.
Okay, so can you generate the entire brief for the developer? We want to redo this code from scratch, and we will be using an experienced developer. So how would you go about prompting them? Can you just generate the final prompt?
This project is about creating a new and improved interactive simulation that demonstrates penis function. The goal is to make it visually realistic and anatomically accurate, while also being educational and easy to use. The simulation should clearly label all parts and provide detailed explanations, making it simple for users to explore and understand how everything works. Key features will include simulating arousal and erection, urination, and a reset option, along with sound effects and adjustable settings like controls for the tunica albuginea and glans gradient. The final product should be engaging, informative, and suitable for educational purposes.
No, it is writing code. It's the first time we are using GPT-5. It made this too more realistic. We have sound. Okay. Yeah, the sound is not great. It's not very correct, is it? No, because, well, get rid of the demo mode. Currently it's swapping the visuals to higher anatomical fidelity. The cross-sectional view, so on and so forth. Cross-section. The cross section is not very useful, is it? This sound is annoying. Hey, why does the cross section look so bad?
So, you press the button and voila, a cross section pops up in the top right. But it kind of looks like two red blobs, a pink circle, and a little gray dot, all floating in a white box. Not exactly the Mona Lisa of anatomy, right? Why does it look like that? The cross-section is a super-simplified cartoon view, two big circles for the Corpus Cavernosa, the erectile chambers, a smaller one for the Corpus Spongiosum, the ventral tissue, and a tiny circle for the urethra. They're just circles, not squished or shaped to fit together like in a real anatomical cross-section. There's no connective tissue, no skin, no shading, and the arrangement is a bit bubble tea rather than medical textbook. The tunica outline is just a thick stroke around each circle, not a continuous anatomical envelope. How could it be improved? Make the Corpus Cavernosa more oval and touching, not just two circles. Have the corpus spongiosum hug the urethra and sit below the cavernosa, not just float. Draw a single, continuous tunica outline around all three chambers, not three separate outlines. Add subtle shading, maybe even a hint of skin or fascia. Maybe label the parts directly in the inset. In short, the cross-section is anatomy for stick figures. It's functional, but not pretty. If you want, I can upgrade it to look more like a real anatomical cross-section. Just say the word.
Okay, can you also explain why do we have the tunica? Why do we have the two sliders? Can you just do a conversational review?
Focusing on the tunica, the two sliders, and the overall interactive experience. Let's talk about the simulation. You've got a pretty cool interactive penis anatomy simulator here. It's not just a static diagram, it's alive. You can poke, prod, and play with it using the controls and sliders. But what's the deal with those two mysterious sliders at the bottom? And what's this tunica thing anyway? Why do we have the tunica albuginea? Think of the tunica albuginea as the superhero suit of the penis. It's a tough, stretchy layer that wraps around the erectile chambers, corpora cavernosa. When you get aroused, blood rushes in, and the tunica keeps everything contained, making the penis rigid. If the tunica is thick and strong, the erection is firmer and stands up straighter. If it's thin or stretchy, the erection is softer and bends more. So, in the simulation, adjusting the tunica thickness slider lets you see how a tougher suit changes the shape, angle, and rigidity of the erection. It's a hands-on way to understand why this layer is so important. What do the two sliders do? Tunica albuginea thickness slider *. Slide it left for a thinner, stretchier tunica, softer, more flexible erections. Slide it right for a thicker, tougher tunica, firmer, more upright erections. You'll see the shaft outline get thicker and the erection angle change as you adjust it. Glans gradient slider *. This one's all about looks. Slide it to make the color and texture transition between the shaft and the glans, the head, more or less pronounced. So, you want to swap out the two sliders, tunica thickness and glans gradient, for a single dysfunction slider? That's a great idea. Here's why it's cool. Why a dysfunction slider? Instead of fiddling with technical anatomy details, you get one big picture slider. Slide it left for healthy function, everything's working as nature intended. Slide it right, and you introduce more and more erectile dysfunction. The erection gets weaker, softer, maybe droopier. The angle doesn't rise as much. The cross-section might show less blood in the erectile chambers. Maybe even the urination or ejaculation animations change a bit. It's like a realism dial for how well things are working. Super intuitive, super educational, and a little bit cheeky. Step 1 complete. I removed the two old sliders, tunica albuginea thickness and glans gradient, from the controls area and from the simulation state.
So after removing two sliders, you're having other issues seem to be on it. Some variables that we were controlling using sliders, now we just need the fixed value, some constants, I would imagine. Okay, we started having trouble after removing the two previous sliders. Can you check the image attached? The animations seem to be wrong. We seem to have, by mistake, removed some important code.
You're right. Based on your screenshot and the code, here's what happened. The animation and shaft are missing because the arousal logic in the animation loop still references the old tunica thickness variable for erection dynamics and stiffness, which no longer exists.
Okay, so can we fix the code? The cross section is kind of useless at the moment. That's what the previous version that we had. Yet the new one is better.
The animation loop and arousal logic have been fixed to use the new dysfunction state, replacing all references to the removed tunica thickness variable. The shaft and animation should now be visible and respond to the dysfunction slider and arousal controls. Let me know if the simulation is now working as expected or if you need further adjustments.
Okay, it's not working well. It used to work better before. Before we removed the previous two sliders, I don't know what happened, but yeah, if we can add some troubleshooting, some outputs into the code.
Let's add a simple on-screen debug panel that shows the current state variables, arousal, urination, ejaculation, arousal level, etc., in real time. This will help you see if the state is updating as expected and quickly spot issues. I'll add a floating debug box in the bottom right corner that updates every frame. Made changes. A floating debug panel has been added to the bottom right corner of the simulation. It displays key state variables, arousal, urination, ejaculation, arousal level, etc. in real.
Okay, I just realized we made a mistake. We were updating the wrong code. Revet. Yeah, we'll have everything eventually deployed on BioniChaos.com. How's this a dysfunction? Okay, can we double check the angles, the trajectory and stuff like that, the angles? So currently in the arousal state doesn't look right. Can you check the code? It was working better before.
The shaft angle and trajectory logic have been updated for more realistic behavior. The angle now interpolates from a downward, flaccid, position to a healthy upward angle for full erection, with dysfunction causing a droopier result even when aroused. You can enable geometry debug logs by running window.debug_geom equals true in your browser console. Try interacting with the simulation and let me know if the angles and movement look more natural now. Here's a quick explanation of what you see in the image. The main white box is the canvas where the simulation is drawn. The shaft, penis, is drawn on the left side, starting from the lower left and curving upward. It is colored pink/red with anatomical shading. The colored circles and lines represent anatomical features. Orange circle, bladder. Pink circle, testicle. Red/blue lines, decorative blood vessels. The cross-section inset, top right, shows a simplified anatomical cross-section of the shaft, with the two Corpus Cavernosa, Corpus Spongiosum, and Urethra. The controls below the canvas let you trigger arousal, urination, reset, toggle sound, and adjust the dysfunction slider. The legend explains the color coding for each anatomical part. Currently, the shaft is positioned close to the left and bottom edges, and the angle/length may cause it to appear cramped or cut off. This is due to the fixed base x/base y and scaling logic in the code. If you want the shaft and anatomy to be better centered and always fit the canvas, I can adjust the geometry and scaling for you. Let me know if you'd like that.
Hey, can you explain the images? Tell me what's wrong. So obviously the initial position of the animation is not great at all.
Here's what's happening in your screenshots and why the initial position looks off. What the images show. The shaft is not starting from a realistic anatomical base, e.g., the perineum or pubic region, but is instead floating in the middle or left of the canvas. I'll fix the code so the shaft space is always anatomically anchored near the bladder and testicle, and the rest of the geometry adapts accordingly. The base will be fixed at a plausible point, and only the shaft's angle and length will change with arousal/dysfunction. This will make the animation look realistic and connected. Here's what I'll do. Anchor the shaft base at a fixed point, relative to the bladder/testicle. Adjust the shaft's length and angle only, so the tip always fits within the canvas. Keep the bladder and testicle in visually plausible positions. I'll apply these changes now. Made changes. The code is now fixed so the shaft space is always anchored at a realistic anatomical point near the bladder and testicle. Only the shaft's angle and length change with arousal and dysfunction, and the tip is always kept inside the canvas. This ensures the anatomy looks connected and realistic, and the initial position will always make sense. Reload the simulation and you'll see the base stays fixed. I'll do both of your requests. Add a debug button to toggle a debug panel, like in your screenshot, that shows the simulation state. Change the animation so the shaft doesn't jump to its default position, but but animates smoothly from its current state after a reset or mode change. I'll implement these step by step and explain after. Made changes. Step 1 complete. There is now a debug button in the controls. Clicking it toggles a debug panel, like your screenshot, that shows the simulation state in real time. Next, I'll make the shaft animate smoothly to its new position after a reset or mode change, instead of jumping. Made changes. Both features are now implemented. There is a debug button that toggles a debug panel showing the simulation state, just like in your screenshot. The shaft now animates smoothly to its new position after a reset or mode change, instead of jumping.
Oh, yeah, so the debug panel, we need some improvement of the position and load it on by default when page loads. But also, yeah, so after the second stage, after browser, whatever, when we click the other button, the animation is too fast. Hope it knows what I'm talking about, because to put filter the terminology.
I'll make the following improvements. Move the debug panel to the top right corner, with a small margin, so it doesn't overlap the main simulation. Show the debug panel by default when the page loads. Reduce the shaft animation speed for a smoother, slower transition. I'll apply these changes now. Made changes. The debug panel is now shown by default and positioned in the top right corner with a margin, so it doesn't overlap the simulation. The shaft animation is also much smoother and slower for a more natural transition. Reload the page to see these improvements. Let me know if you want further tweaks. I'll address both issues. Animation is too fast after reset or state change *. I'll slow down the shaft's animation even further for a more natural transition. Urination in the default, flaccid, position doesn't look right. I'll adjust the urine particle emission so it always follows the shaft's tip direction, even when flaccid, and tweak the angle/jitter for realism. I'll make these improvements now. Made changes. Both issues are now improved. The shaft animation is much slower and smoother after reset or state changes. Urine emission is now more realistic. When flaccid, the stream is slower, more downward, and has more spread. When erect, it's more forward and focused. What the image shows. The penis is in a flaccid, non-aroused state. The shaft is short, wide, and angled downward. The user has pressed the urination button, so yellow urine particles are being emitted from the tip. The urine stream appears to fall almost straight down, with a wide spread and low velocity. The bladder and testicle are visible, and the debug panel shows is urinating, true, and a growing particle count. Why the urine looks like this? Flaccid state physics *. When the penis is flaccid, the shaft points downward and is less rigid. The code intentionally makes the urine stream slower *, lower initial speed, so particles don't shoot far. More downward *, a downward angle bias is added, so the stream falls almost vertically. Wider spread *, the stream is less focused, with more random jitter, to simulate the less controlled flow of a flaccid penis. Particle system *, each urine particle is emitted from the tip, with its own velocity and gravity applied, so the stream quickly falls and spreads out. Visual result *, the urine appears as a short, wide, downward falling spray, which is anatomically accurate for a flaccid state. Why it looks not great. Realism versus clarity *, the simulation is prioritizing anatomical realism. A flaccid penis cannot direct a strong, focused stream, so the urine falls downward and spreads. Visual overlap *, because the shaft is short and close to the testicle, the urine may overlap with the testicle or base, which can look visually crowded. Particle accumulation *, if you keep urinating, many particles accumulate at the bottom, which can look messy. How to improve, if desired. Make the urine stream slightly more forward, even when flaccid, for better visual separation. Reduce the spread or increase the initial speed a bit for clarity. Fade out or remove old particles faster to avoid visual clutter.
Okay, I will finish this next time. You'll have two versions, so we'll check which one is working better. And everything we do is available on BioniChaos.com. Go check it out, provide your feedback, and I'll see you next time. Bye.